So let's get started, guys. This course that what we are doing right now is big data using Hadoop and NoSQL. So I'll do a quick intro of the entire session and how this will be structured. So a brief course outline. We start with introducing the audience to the big data. We talk about big data. How big data has been available for long, and we talk about big data, and we talk about what are the core characteristics of big data. And once we talk about big data, once you get an understanding of what big data is and how it has been it is being handled previously by different distributed systems, we quickly introduce you to Hadoop. Okay, so introduction to Hadoop is what we talk about Hadoop being a solution which will help you to tackle the big data and in an efficient manner. When I say efficient manner, how Hadoop provides you solution in comparison with your traditional distributed systems and what are the advantages with Hadoop. So with introduction to Hadoop, we'll talk about what are the core characteristics and what are the various components of Hadoop. So we talk about HDFS, we talk about MapReduce. So all this will be introduced to you during this duration of this course. And once we introduce you to the concepts, the core concepts, then maybe today, if we get some time, today we'll also do some kind of a demo. So I will show you how the demos will be structured going forward for this entire course. Mostly the demos are done using the Amazon AWS micro instance, and this instance is what will be shared with you. So Daniel will share with you guys a private key and also an IP address. So where you need to just log into the party session and you can set up it. You can do the installation yourself. So the prerequisites for the installation I will show you today, and by the time maybe when you come back tomorrow, what I would want you to do is if you just start the install, at least install Java and keep it ready so that you can get a hang of what we are showing you here. Now once we talk about intro to Hadoop, once you get a hang of it, we'll move on to Hadoop administration and how Hadoop administration will be, how you can set up a multi-node cluster and how you can do a high availability. Primarily, when you talk about high availability, so we are talking about Hadoop 2 features. So with Hadoop 1, which is very older version in comparison, maybe right now we are having Hadoop 2 as the latest version, and Hadoop 2 has a lot of advantages. So while doing this session, whenever we get a chance, I will try to explain the differences between Hadoop 1 and Hadoop 2 as well. But primarily, almost in the industry right now, everybody is moving to Hadoop 2, and Hadoop 2, the core reason being Hadoop 2 has a lot of advantages in comparison with Hadoop 1. So there are a lot of disadvantages, like there is a single point of failure, there is no namespace or name node extension, or you can say horizontal scalability. So all these things you'll get to understanding, and we'll talk about these features. Then we'll spend time on Hadoop development, how MapReduce processing will work, and what are the various tools we have, right? Like Scoop, Pig, and Hive. We talk about these tools, and we'll show you like what are the advantages, and how even without any person, even without a Hadoop background, can simply run queries on your can run a MapReduce program on a Hadoop cluster. So it doesn't mean that somebody, because if you say Hadoop is purely a Java-based framework. Now it doesn't mean that we only the Java developers should be running Java programs or MapReduce programs, because in turn what will happen, the programs that run on Hadoop are actually a Java programs, but in the industry you have people who doesn't know Java also. So there are people who are running on SQL program, like say database people. There are people with .NET experience. There are people with Python experience. So we'll see during the development session how people with varied backgrounds can actually run their actual programs, and which in turn would be run as a MapReduce program on behind the scenes. Okay. So this is what we'll see, and And then we'll do a NoSQL introduction. And again, the reason being this course is structured in such a way that typically outside people will give either administration, either development or NoSQL. But this is structured in such a way that we cover all the core components, what is required, and based on your requirement, based on what your interest would be, you can go down that path. So we talked about NoSQL. Within NoSQL, we talk about MongoDB, Cassandra, and we see how the data, we see differences between your traditional RDBMS and how NoSQL is coming into picture, and how NoSQL leverages your Hadoop cluster, or how NoSQL data is residing on your HDFS layer. Then we will spend some time on cloud and big data. We'll see the differences and how people have actually started setting up their instances on cloud instances. The reason
I was on a call. Yeah, Kumar. Okay, fine. I'll do that. Sure. Thanks.
Samba, are you back? I think we lost you on your connection.
I'm back.
On your audio. Hey, Samba. Okay. There is also a slight disturbance coming in. Daniel, can you mute other people as well?
Kumar, were you in class? Like for last 10 minutes, I cannot hear anything actually.
Yes, Kodeshwar, I'm doing it. So we're just waiting. I mean, we lost Samba, so we're just trying to get Samba back in and waiting for Samba to get in. And there are some questions coming in, so I was just trying to wait and see if there are any questions coming in and address them.
Okay. So you were trying to address the questions like offline or something, or like?
No. I'm not doing offline. As the questions come into the chat window, I'm trying to address them. So, I mean, Khan has a question about the course, so I'm just trying to explain that part.
Got it. Okay.
Okay. So no, I'm not be doing it offline. So everything, whatever questions that get into the chat window, I'll try to relay them to the audience. So he has a question on. So Khan's question was, how is this course is structured, and how do we need to? I mean, do the students need to learn anything additionally? So I was trying to say that basically outside people will give either a Hadoop administration course or Hadoop development course, or you talk about NoSQL. So the reason we have integrated all these three together is because I mean, once you learn the core concepts, and once you understand development, administration, and the NoSQL databases, you can choose to go down whichever path you would be interested in, and you don't need to do any additional courses. So the only thing that you need to do is spend as much time on your understanding the basics, and I mean spend as much time on try to get your hands onto the practical sessions. Okay, the more practicals you do, it's the more experience you get, and that is what is counted. And most of the questions, or I mean most of the currently industry is trying to see how much basic understanding you know. Okay, so as the industry has still not matured on the big data, so people, or I think the companies are right now looking for people who are strong in their basics and who know a little bit of administration part. And if they, I mean, it's like people who should be able to work on their own, knowing the basics. So that is what the current industry is expecting. And the reason I say this is because it is not yet matured, and you have a very shortage of skills right now, and really no experienced people available. So being started now, I mean, you will have a head start advantage, or you have a first start advantage. And if you know the basics, I think I'm confident that you guys will be able to crack anywhere. Okay, so that's about the course and how this course is structured. Okay, because and you can see here that we are talking about multiple streams. We are talking about administration, talking about development, talking about NoSQL, talking about indexing and searching also, right? So Solar, Lucene, we'll talk about Hive, we'll introduce in here. Hive, we'll talk about Pig. I mean, these are different ecosystem packages, right? So Hadoop in itself will not assist you. Your Hadoop HDFS and MapReduce is not something which will provide you a solution. You need to have other projects, okay, which are like Scoop, Pig, Hive, which we call as a ecosystem project. And why it's called an ecosystem project, maybe I'll explain to you down the road. Okay, so these ecosystem projects, once you have an understanding of this, I'm sure you should be able to. You should be good in the market. All right. So I mean that's a good. I mean let's start with the actual course, and let me straight away jump in here. And before that, the way we show practicals, I'll just explain, and I'll spend a little bit of time on how we do the practicals. Right, so you will be provided with an IP address and a key, okay, a private key and a public key will be provided to you. So using the IP address is what you actually log in. Just give me a second, guys. Oops. Let me close this. So you will need to, most of these demo sessions or most of the practical stuff is actually done on Amazon instance, right? So either you can do on your own machine, like you say on your, you can have it on a VM player, because the reason being we need to have multiple machines. Okay, we talk about clusters, so we need to have multiple machines. So either you can have everything set up on your own machine. Again, that there will be a limitation because it is again dependent on your memory, right? So if you have an 8 GB machine, you cannot spin up more than four VMs or 5 VMs. So what I would suggest is we would be providing you with an IP address and a key, and you need to log into that PuTTY session. And once you log into the PuTTY session, so just follow the instructions, whatever instructions I would be showing you, and I would also be sharing you the instructions. And you just need to follow the instructions. You set up your own cluster, you set up your own machine, and from there you can pick up. All right. Again, these demos are primarily done on Ubuntu, right? So this is if I show you the version of Ubuntu. So the demos are primarily done on Ubuntu 12.4. This is the latest version available, and everything would be on your Amazon AWS instances. So these IP addresses will be shared with you, and once you have the IP address, you can PuTTY into the instances using user ID Ubuntu. Okay, so the Ubuntu is what will have the user ID Ubuntu will provide you sudo privileges. That means you can actually install everything. So sudo privileges is something which will help you install. When you let's compare it with your Windows, right? When you want to install anything, you need to have a root permission or admin privileges. So sudo will help you to install everything, all the packages. So I have a quick question coming in. So question is from Ram. Do you provide exercise which covers all the aspects of this training? Yes, Ram. There are lab sessions, so we do provide you with the lab sessions, and we actually handhold you. In case you have any questions while doing the practicals or the lab sessions, you can always get back to us, and we have a strong team. So the team can assist you with actual installation and also understanding these exercises. Samba is asking, can you please brief about Amazon AWS? Do we require to install Ubuntu then? Can I do it in Mac? Okay, let me address Samba's question. Can you please brief about AWS? So Amazon AWS instances, right? So what Amazon provides you, like say, a virtual machine, right? So on the AWS instance is what you don't need to worry about that aspect. What we have taken care of providing you with the IP addresses, right? So we will provide you with the host IP addresses. So you only need to log into the machine, right? So this is how like how I logged in right now. You can simply, let me show you that aspect, that part also. So if I go here, a new session. So this is the Hadoop demo is what I have actually saved it here, right? So if I say load, so this is the IP address, right? This is a public IP address which will be shared with you people, right? So an IP address, and this is a DNS name. Okay, so an instance. So what happens is, Excel Frameworks has an account with Amazon AWS instance, and we can spin up as many instances as we want. And once we spin up those instances, we will set up for you. Okay, the server and all will be set up for you. You only need to take the IP address, what I'm showing you right now here. Take the IP address, okay, and you start logging in, right? You do a SSH in here, and once you open a session, right, so you'll be prompted to enter the user ID password. So Ubuntu, oops. So this is this is because the link has changed. The password link has changed. Hold on 1 second. Because you will be provided with a key also. A key is where authentication key you need to load. So if I load this part, let me show you this. So there will be a key which will be shared with you. Okay, so the key will be ending with .ppk, and once you add this key, so what I have done is I have actually entered the hostname IP address in here, right? Whatever IP address that we are sharing you, or whatever hostname that we are sharing you, you enter the hostname IP address in here, and go inside the SSH, right? So this is a PuTTY session, guys. So PuTTY is something which you can download, right? This is a freely available download available, so you can download PuTTY. This is a tool which will provide you to log into your Linux sessions. Okay, you can replicate your Linux sessions. So this IP address, I have actually entered the IP address or the host name. Then I go inside auth and provide the key, okay, the key which will be shared with you. So these two aspects, don't worry about this. The IP address, the host name, and the key will be provided by us. Okay, so it will be sent to you separately, individually. So each of you would be having an account for yourself. And once you have it set up, what do? You go here, load this. I have a saved session here, so I'm loading it. Or you can simply click on open. Okay, so once you click on open, I'm able to open the file Cassandra key. Oh, so we're still having the old one. Let me fix that part. Change. So you are logging as user ID UBUNTU Ubuntu. Okay, it will not prompt you to enter the password. The reason because we have a key added there, so it will not prompt you to enter the password. And there you go, you are already logged into the machine, right? So if you do host name, so it is giving me an IP address which is a public IP address. So we'll show you. We'll show you the instructions on how you can change the host name, how you can change the host name to a master and a slave, right? So as I do the demo session, I will explain to you this part. Now the next question is from Amin. Amin is asking, do we require to install Ubuntu then? Can I do it in Mac? Right. So Amin, you don't need to install Ubuntu, because when we provide you with the IP address and the key, this is what you need to do. Just the steps that I have showed you right now. And once you are logged in, you actually have an instance spinned up for you. So this is etc. If I do issue. Right. So this is the Ubuntu installation which has already been installed. Okay, so installation, okay, setting up a server, setting up operating system is all done for you. So from here on, whatever is required, whatever the prerequisite from here on, like say installing the Java, installing the Hadoop packages, is all what you need to do. And all this we have everything documented, and we will provide you with the instructions. I will show you the instruction first, and once I show you the instructions, you can take that as an exercise and do it yourself before you come to the next session. Okay, and all these login, right now you're logged in. I'm logged in as user ID. If I type ID, right, or you can do who am I also. So this will provide you what is the user ID you're logged in. So this is the ID. The ID would be Ubuntu, right? So and Ubuntu has got sudo privileges, that is everything is taken care for you guys. So you don't need to worry about it here. You don't need to worry about setting up the server, setting up operating system, setting up users. So everything is taken care for you. That's the primary prerequisite. From here on, we need to have Java installed. Like say there's a Java-based application. So if I want to have Java, because it doesn't have Java right now, right? So when I give Java -version, I'm querying the operating system to see if my Java is installed or not. Right now Java is not installed here, so I will show you how to install Java, how to set up your packages, and I will show you from here. If I also give, let's say, Hadoop, right? So if I give Hadoop, it says Hadoop command is not found. Now once I install the packages, once you install Hadoop, download the packages and all, you will see, you will be able to execute Hadoop commands. So this is how the practical session will be structured and how it is oriented. And if you have any questions while doing the practicals, right, you can always come back to us. So clear with this, guys? Are you guys on the same page? Can you guys confirm? Okay, perfect. Thanks, Samba and Amin, for confirming, acknowledging. Now we talked about the course outline. We talked about how we just wanted to do a quick intro on what all topics are covered, okay, and also how the demos would be done. Now demos, again to Amin's question, you can install on your own machine, right? But that is not suggested, because that requires a lot of setting up. Like you need to download a lot of like you need to download your operating system packages, you need to download your VM players and all. Once you download the VM players, you need to install the operating system. So that is not, it is not something which is not suggested, but this is, the server is set up for you. Once you have the server, you can install everything in there. Now Ram is asking, can you please give some brief overview of exercises in each area? Right. So yes, definitely, Ram. Now, like if I say introduction, or okay, let's come back here. So here is where your actual Hadoop administration would begin, right? So the exercises would begin up here, where we show you how to install a Hadoop cluster. Okay, we start off with a single node cluster, right? So basically, okay, let me exit this. Basically, see, there are multiple ways of installation. The primary one being, I mean, when we talk about administration, I will tell you about installation on a single node machine, pseudo distributed machine, and a fully distributed machine. Now, single node machine is something which is only for development purposes. Now, pseudo distributed is what we will start off with. So, pseudo distributed mode is where you will have all the processes running on a single server, right? On a single server you have DFS available. So we will provide to you how to install pseudo instances on the cloud instance, okay? And from that we will expand onto it, okay? So installing with I will show you the demo part on pseudo installation, then we'll expand on that, we'll build upon what we have learned till that time and expand it to a multi-node cluster. So Ram is asking, is there any project involved? Yes, Ram, there is a project involved. So the project is something which there's a live project that will be given to you guys. So definitely everything will be addressed, and each of these, right? So each of these there will be a practical session, and practical session is what I do on myself, show it to you the demo part, and which will be a takeaway for you before you come back for the next session is something which you need to do hands-on experience for you. So you need to experience for yourself. Divya is asking, can we get the recordings of our class? Yes, the recording will be available definitely. Do you cover cloud installation as well? Right. So Ram, the installation is what is all being done on the cloud, right? This is all actually what you're seeing right now. The IP address. This is IP address from the cloud instance only. So all the installation will be done on the cloud itself, not on the single node machine or on your laptops. So Ram, are you good here? Khan is asking, I have no programming experience. Do you recommend this course? If there is any question in exercise, do we need to wait until the next session? No, Samba, if you have any questions, you can always drop a mail to our support, okay? And we will try to address, and we'll address as soon as possible, okay? So you don't need to wait for the next session, or you can also reach out to us, send an email, and maybe one of our guys will reach out to you and help you with that. And Khan's question, I have no programming experience. Do you recommend this course? Definitely, Khan. You don't need to have a programming experience. So as I said, from an administration perspective, yes, no programming experience is required. And if you see right now, people who are learning Hadoop, right? So you have database administrators. So database administrators do not have any experience on Java development, but they can still write their queries, right? So what they are good at writing database queries, your typical SQL queries. So there is an ecosystem project called Hive. I will provide you a HQL. Okay, it is a Hive query language is what people write queries in. Now HQL is exactly very much similar to what a database administrator writes. So it's a SQL query, right? Similar to that, exactly same syntax and all. You can still run a MapReduce program, right? So you are writing a Hive query language, which in turn is converted into a MapReduce program, which is a Java program. So you don't need to have a Java Java knowledge, or you don't need to get a Java programming experience, but you can still be able to administer your cluster, and you can also use development part, right? So if you are good at shell scripting, you can leverage your shell scripting and Python skills and still run a MapReduce program which will run on the cluster. Okay. So Ram is asking, is there any difference between a standalone installation and a cloud installation? Right. So standalone installation is something which we do on a single node, Ram. Okay. So you'll get more clarity on that part when you do that demo actually. So standalone is what? Standalone instance is having almost all the daemons, every daemons on a single server. Now what is a daemon? That's what I will explain to you again. So all the processes that are participating in your cluster should be on a single machine. Now, cloud instance is what we install on the cloud. Okay, from a learning perspective, at this point of time,
Hello, Kumar, are you there? Hello.
Okay, that is also being used in the production environment, and there is an Oracle instance, right? So OEL, which is called OEL, Oracle's Enterprise Linux, which is nothing but a wrapper wrapped around of RHEL. Okay, RHEL is again Red Hat Linux, right? So Oracle has taken Red Hat Enterprise Linux, so wrapped up their own packages, and they provide you as an OEL, Oracle Enterprise Linux. So these are the different operating systems currently supported. Right, so the duration of the course would be about 35 to 40 hours. Okay, we'll make sure we'll cover everything. Is the installation and configuration same in all operating systems? Exactly, Ram. So there might be slight differences in the way you execute your commands. Okay, so see, the prerequisites is what setup might be differing, but when you install and configure installation and okay, let me address this aspect. So the configuration aspect is no changes. Okay, once you're done with the installation, the configuration is exactly the same in whatever operating system you're doing. Now coming to the installation, so installation might change a bit here and there depending on your operating system. Okay, so that again you can go into the Cloudera package or Cloudera download location. Like say Red Hat Linux and SUSE Linux, you can download an RPMs, right? You can install with RPMs. So I mean, so there are slight differences. So as we do the session, I can also address those queries also. I mean, if you are interested in a specific question or a specific operating system, I can provide you the details on how to install on that particular operating system. Right. So as Daniel has said, the course would be about 40 hours course is what we are planning to do this. Okay. So we'll have everything covered in about 40 hours, and all this will be I mean, all these topics, all this what we have talked about till now will be included, or apart from theory, practicals will also be, the lab sessions will also be included in there. All right. So great. Any other questions, guys, before I actually start? So I just put this chat window onto the top so that you can see my screen. Right, thanks for the comment, Samba. So good, guys. Just want to make sure you understand what you guys will be going through for the next 40 hours or the next couple of 3 to 4 weeks, and that's what we want to make sure you get a good understanding of it. And we also at the end of this session, right, at the end of this practical or this course, you should be able to yourself come up with a solution for any or you can say any problem that is given to you, you should be come up with a solution. So you can be, as an architect, you can come up with a solution and say, this is what is the requirement if you have this much of data capacity. So this is what is the requirement. This is how you set up, or whichever operating system you set up, right? So that is what the end objective of us is, and that is what we want to get the students to that level where they can come up with their own POCs. You can create your own POC and provide it as, I mean, that will add value to your resume also if you say you have done a POC. So as I said, the industry is maturing right now. It's in a very, very nascent stage, and people are still not up to, or we don't have experts really, do not have very, very good experts. And if you come up with a POC on yourself, that is a good head start for you people. All right. So with that said, now let's actually move on to the first part of this session, right? So we're talking about introduction to big data. Let me just give a minute, guys. Right. So we'll today we'll do with introduction. Okay, we'll talk about what are the characteristics of big data and how you can categorize big data, right? So I will try to explain to you how why we are actually talking about data, right? So let's see why are we actually talking about big data as a solution, or what exactly is this big data? So big data is something is actually big data is not a solution, right? So big data is something, the data which has been available for quite some time. Okay, so it has been available for, it has been there for a while, and data is there from the time you have your computer coming out, right? So from the time you have your computer, data is available. Okay, so Anthony just joined. Just give me 1 second, guys. Now, let's spend some time on the theory part. Okay, we are done with the introduction, and let's spend some time with the theory part, right? So why are we looking at big data, and what is the requirement why we are looking at solution? Now the reason we need to talk about data is because within this data, whatever data is available for us, right, in that data there is a lot of hidden information. Say for example, any e-commerce site. So the e-commerce site, any e-commerce site, what you do, you actually log into an e-commerce site, try to browse some items and log out, right? Or you try to purchase an item, and while doing this purchase, you will try to do a comparison between multiple items of, like say, a mobile phone. You want to purchase a mobile phone. What you do a comparison. You browse, you go onto the website, log into the website, browse a lot, and see to the comparison. And at the end, you come up with a decision that you want to purchase a phone which has got high features or a very good features. Okay, now how this decision is made by you, by one person, is what is all captured by this e-commerce site, right? The reason being, they capture this information so that whatever decision you have taken based on your research and your requirement, what they want to do is they want to provide this as a solution or provide this as a recommendation for some other customers. Okay, now when they provide this as a solution for some other customers, so next time, let's say you have, let's say today I want to purchase a mobile phone. I log into the website, I do a search. Now if you scroll down to the bottom of the screen and see, there will be a recommendation. What it will say is people who have searched for this phone, okay, or who is actually purchasing this mobile phone, or also purchasing an additional battery, or also purchasing an additional charger, because the battery, though it has got very high, all the features, the battery will not last for a long time. So they are actually purchasing an additional travel charger or additional battery. So what will happen is, it is almost possible that you will actually go by the recommendation and you will actually purchase that particular additional item, right? So apart from the phone, what the e-commerce site has done now, they have increased the revenues. Right, so that's their objective, right? So for an e-commerce website, their objective is to increase as many sales as possible and let the sales happen at this current time rather than happening at the future time, right? So how does this decision is all this decision is happening? The decision is happening because of previous history, right? Previously, people have actually purchased so and so products. They did a research, and all this information needs to be captured and put into some location. Now there are a couple of challenges here. How do we store the data, right? So to store the data, storage is expensive for you. Now when you have to put so much of data on a storage, you need to invest millions of dollars for a single storage server, right? So to avoid that, now we have the problem. The problem is you need to capture all the information, store it into one location, right? Why you need to store in one location? Because you need to run some analytics on that part, right? So you need to run some analysis and come up with a campaign or come up with a solution, future solution. Right? So the solution is what? The solution is will help you to increase the revenues of your company or your e-commerce site. So as I said, as an example, the recommendation, whatever recommendations you are getting, right? You will see almost on all the e-commerce sites right now. If you go log in and search for anything, at the bottom you will see a recommendation. Now this is something which Amazon has introduced the first time, and when they introduced the recommendation the first time, they claim that they have seen a revenue jump of about 30% increase in the sales revenue. Right. So in the moment everybody got to know that they are seeing revenue sales increase, now you will see the same feature being provided in almost all the e-commerce websites. Right. Most of these are providing you these recommendations. Now, to provide you the recommendation, you need to capture all the information. People who are logging in, who are just browsing it casually, everything should be stored. And you have so much of data which you have captured, and all this data should be stored some location. And once you store in a location, you need to run your analytics on that. Previously, now you can come back with say that this has been there for a long time, data is being stored. Now it is, if you have to spend more expensive, right? So I mean, if you want to, like say your 1 terabyte of data is what it is generating every day. Now 1 terabyte of data, so it's right now the storage server will cost you, I mean in enterprises people will charge you about per GB, right? So if a BU, a business unit, is what is purchasing the storage server, so the company will say this is what the chargeback is. You will be charged back per GB is what you, I mean the usage is what you will be charged. Now to avoid that additional cost, you need to look at a solution. On to first thing is how you can store the data. Now, second thing is, while you store the data, you also need to do some kind of analysis. That is you need to run some programming on it, right? So what is that analysis? The analysis is the end result, which is nothing but your recommendation, right? So how is this analysis done? The analysis is done on the entire data that is captured. Now you can also say that the analysis was done previously. Yes, analysis was done previously, but it is done on a limited data. Right? Previously, you discard some data, like say you capture 1 terabyte of data. Now you need to discard. You have to, because of the limitation on the storage, you are discarding about let's say 500 GB of the data. So you are running your analysis only on the 50% of the data. Now you have actually discarded the remaining 50% of the data, and there are chances that very, very valuable information would be available in that 50% of the data. So in order to avoid, or in order to not to discard any of the data, we need to look at a solution which can store all the data. That's where we call about commodity hardware, right? So in Hadoop, you will come with the terminology commodity hardware, which is less expensive. So I mean, when we actually come to HDFS, I will explain that part to you. Now, so we have a problem and we have a solution available. So to tackle this problem, what we need to look at, and to tackle this problem using, I mean, the solution is run your queries on a huge amount of data, and that too, the queries should be run at a rapid pace, right? In the sense, it should not take like you have 1 terabyte of data, it should not take forever, or it should not take like say hours together to come up with an analysis. So you need to run you need to run your program or your analysis at a good pace or at a shorter time frame, so that it is available and you can use that data, you can use that analysis to come up with a conclusion. Now with your traditional distributed systems, analysis, right? So whatever analysis you are doing will take a lot of time. Okay, so let's say one job being done by one person would take about 10 minutes. The same job, if it is done by 10 people, right, 10 persons, this can be accomplished in 1 minute, right? So the same principle applies here. The more number of servers that participate in the cluster, the quicker or the faster your output would come up. Okay. Now the second point that we are seeing is sources of data has increased, right? So traditionally, if you see previously, we don't have internet, right? And right now with the internet as a primary driver, so much of data is being generated, your log files, right? So the people log in, they do browse, there is so much of log files generated, and these log files will contain a lot of hidden information. Right? So you say it as a golden pieces of information is what is available in your log data. Now the three characteristics on how you can define your data, or what are the 3 characteristics that you can apply for any data is the volume, the variety, and the velocity of the data. Volume is the amount of the data that is coming in, right? So variety would be different kinds of data, right? Different kinds of data in the sense, if you look at Facebook as an example, Facebook, what you put, you will update your text messages, you will update your video files, you will update your images. So it's not a single kind of data. It's not all the data is not text file, all the data is not videos, or all the data is not images, right? So different kinds of data. So that is where the different kinds of data, not a single structured data or not a single type of data, but your solutions should be able to hold these different kinds of data. Now, the third point is velocity, right? So velocity is the speed at which the data is coming in. Okay, the speed, like say, let's take the example of a New York Stock Exchange. So if you have if you have ever actually watched those news during the timestamps or during the time when the trading is happening, you will see that some of the stock price will be going up, coming down. The last 2 points, right? The last 2 points is what is called tick. Okay, so these ticks keep on going up and down, right? So that is the rate at which the data is coming in. You need to capture that information, right? Why do we need to capture that information? The reason being, using this information, you can predict that the stock price will go up during this time, or the stock price will come down during this time. So not only a stock price, you can also take the example of Twitter as an example. So you have a famous star tweeting something, some important message or some message, a famous star tweets, and you'll have so many followers retweeting it so many times, right? Within a fraction of minutes, you'll have so much tweets, the tweet getting retweeted. So that's the velocity at which the data comes in. Now, anytime you have a doubt, right? Anytime you have a doubt, apply these 3 V's on that data and see if this data meets these 3 characteristics. If the data at hand meets these 3 characteristics, then that's where you need to look at a big data solution, right? That would be considered as a big data. Okay, so apply these 3 V's, the volume, velocity, and the variety, and see if the data matches these 3 characteristics, and it will be considered as a big data. Now you have the big data available. Now what is a solution for it? Right, solution is adopting to big data technologies. So now you know what big data is. Now you have data, so much of data. This is not being handled. It is being handled previously, but there are some disadvantages. Right? There are some disadvantages which have been overcome or which is being addressed in a big data solution. So look for a technology which will help you to solve these problems, apart from assisting you to tackle or bring you the solution. Okay, so chat window. All right. Now existing capabilities right now. If you look at the machine that you're sitting in front of, so it would have about 500 GB of the data, right? So let's say 500 GB of disk space or 1 terabyte disk space. Now, when it grows beyond 1 terabyte of disk space, what you need to do, you will actually need to look at solution, or you actually need to look at ways to increase the disk capacity of your machine, right? Either you come up with a new hard disk or with a hard disk of new capacity, or come up with a new additional external hard drive, right? So your data is beyond, it keeps on extending. So you talked about megabytes, you talked about GBs. Now we'll talk about from here, going forward from here, we'll talk about terabytes and petabytes, right? Because see, that is the amount of data we are talking about. So you need to look at a cluster which can tackle your petabyte scale of data. And huge amount of data is what we are talking about. Now, so static, any analytics you can do, dynamic log analysis or real-time analytics, right? So as the data keeps on coming into your system or into your whichever as a location, whatever data is coming inside, you need to look at how you can analyze the data on real time. Right? How you can analyze the data in real time. So that's where your traditional systems are lacking or providing solution, and that's where you are looking at a new solution, and that new solution is nothing but what we are going to do the sessions going forward. Now, what exactly is big data? Big data is maybe if you can typically give it as a theoretical explanation, right? So in theory, or if you see as a explanation of, or if you come up with a scientific explanation or exact big data. Big data is a term for a collection of data sets so large and complex that it becomes difficult to process using on-hand DBMS tools or your traditional data processing system, right? So two important things here: collection of data sets so large, very large, and complex, right? So complex and large data sets is what we are talking about. So this data set, right? So you're huge data which is not being able to handle with your traditional on-hand database management tools or your traditional distributed processing systems. Now I'll give you an example. Like say you have a 500 GB of data, okay, and compare it with your RDBMS. So your RDBMS, you run a query on your 500 GB of data, it will give you an output in a fraction of seconds. Now look at the new solution that we are looking at. Like say Hadoop, we talked about as a solution, right? So you have the same 500 GB of the data. Now run the same query, or run the same query, or as an example, run the same thing on your 500 GB of data on your Hadoop cluster. What will happen is it will take about 10 minutes to come up with a solution or come up with the results. Now increase the data by about, like say, 1.5 terabytes, right? So we are increasing it 3 times. Now your RDBMS might slow down a little bit, right? Because it has to go through all the indexing, it has to search all your data, and the result, the output will slow down in your RDBMS. But when you're with your Hadoop, the output will still come in the same 10 minutes. Okay, so it will still come. You increase the data to 1.5 terabytes, it will come in the same 10 minutes. You increase it to, like say, 1 petabyte, or increase it to, let's say, about 10 terabytes, your output would come in the same 10 minutes. The reason being, you have multiple servers working on this as a solution. So this is where we talk about Hadoop being provided as a solution, and where your traditional systems do not, or where your traditional systems will slow down. That's where you need to look at a Hadoop as a solution. So Hadoop will be a solution to handle this additional data, the data that is so huge. Now if your data is not meeting your 3 characteristics, and if your data is not so huge, you do not go for a Hadoop as a solution. That is because, as I said, your traditional systems will give you the output in a fraction of seconds, and you need to look at Hadoop as a solution when your data is increasing when you talk about petabyte scale of data or terabyte scale of data, right? So that's where this clearly tells you that it becomes difficult to process using on-hand database management tools or traditional data processing systems. Now, some of the examples that we are talking about here is operational data as solution stock market, right? Stock market is one of the best example you can give. The volume, the velocity grows because data is dynamic. It keeps on going up and down, and dynamic search is required also there, right? So dynamic search, dynamic updates, you need to insert, deletes, everything happens so frequently on your stock exchange, right? Now to handle this kind of data, it is not a. Now we talked about, if you say RDBMS and with relational database management system, which strictly adheres to your integrity rules, and everything should be a structured data. But when we talk about the volume of the data, we also talked about the variety of the data, huge data, which is different categories of data, which is not a single structured data, right? So this data will not fit into your traditional RDBMS, which is not a structured data, and your log files are not your structured data, right? So you need to look at a solution on how to handle this unstructured data, and that's where you will get to talk about your NoSQL. Right? NoSQL it doesn't strictly adhere to integrity rules or the ACID properties of your SQL, your RDBMS parameters. So any data that you want to analyze, whatever data you want to analyze, you need to look at a solution where you can load the data. So that database, what we talk is NoSQL database, and out of those NoSQL database, we are talking about MongoDB and Cassandra. So normally it comes as MongoDB. Typically people when say Mango, so that's why I just came out as a MongoDB. So it's MongoDB and Cassandra which will provide you a NoSQL solution, and that is what we are also providing you in this course. Okay, we'll talk about MongoDB and Cassandra as well. So data is static, but volume and variety is huge, and you want to do analytics. That is predictive analytics. So analytical. So what kind of analysis? Right now, analysis. Another example would be when you say when you talk about let's say Sears. Sears is again one of the retail industry. I mean one of the biggest major of retail company in US. Right. So that is primarily taken as an example in the IT world, in this big data world, because they have implemented or they have replaced all your traditional systems with a Hadoop as a solution. And now once they come up with they have replaced, when I say they have replaced, right, because they are storing so much of the data. Now talking about a retail store as an example, how can they actually, in what ways they actually use the big data as a solution? Take for example, let's say one person comes and purchases a product every month, right? So let's say a beauty product, or you go for a soap or anything, any beauty product a person is coming to the store and purchasing every month. Now they have analyzed this data for the last history, like say since the store has started, or like say for the last 1 year or 2 years, compare this data and see this person is coming every month and purchasing this beauty product. Now what if we can sweeten the deal? If this person, or if a person is purchasing this beauty product, you will get an additional offer, right? Like say you take this, or you can say you purchase some other item, you will get an additional 10% discount or a 20% discount. So what they have done is, when they implemented this as a solution, they have seen an increase in the revenues, because this person comes every month, purchases this item. The second item may be useful or may not be useful, but because there is a discount available there, right? So people might fall into the trap and try to purchase that, right? So they have, not only this, they also analyze, right? They do analysis of the entire data. Now when they want to do analysis of the entire huge amount of data, where do they store the data? They need to store the entire data, and then on the 100% of the data, they need to run their analytics. Okay, so that's where we talk about big data as a solution. So guys, any questions so far? Please let me know. Are you understanding? Are we on the same page? Let me also know if I'm going too fast or if I'm going too slow. Please let me know. Okay, thanks Divya, thanks Samba for acknowledging. So okay, so let's move ahead. We'll spend another about 20 minutes on your theory part, and then I'll also see if I can get. Yes, somebody has a question. Please go ahead.
Kumar, this is Samba here.
Yes, Samba.
I have one question, Kumar. Like, I know big data is a bit expensive when compared to relational databases. So, if you have I just want to understand when we really need to go for big data. Like, if you have a smaller quantity of data, just like 2 or 3 tables, and it is a flat structure of data, is it worth to go to big data? Or when we have a different varieties of data, then only we need to go for big data?
Right. So 2 questions here, right? So in what cases we need to go for big data? So the reason, previously explained, right? So your traditional RDBMS will provide you. So if you have 2 tables and your query will run within a fraction of seconds, right? Your output will come very, very quicker. Now you have 2 tables of data and you implement big data as a solution. What I said is your output will still take about 5 minutes to run this job, even though you have only 2 tables. So as the data scale increases, right? As the data is increasing, so use your traditional system, and at a point where your traditional data DBMS tools will slow down, will provide, let's say 1 terabyte of data is what I think the traditional DBMS may not take care, right? So they will slow down when there is a huge amount of data is there. 1 terabyte of data is very huge. So when it slows down, that's where you need to implement or look for a solution, which would be your big data solution, and Hadoop is what we are talking about. Does that address your question?
Yes, Kumar. So are you telling that so we can still use the big data for flat structure files as well?
Yes, you can still use
data.
Yes, see, you can still use it, but see, that is not advantageous, right? So if you have very less data, it is you don't need to spend millions of dollars, right? So you're spending so much of amount, and which is being handled by your traditional system. So look at a location, look at big data as a solution which will handle huge amount of data, and also use the variety rule, right? The variety, see the different kinds of the data. Whether this data is, because see, in your traditional RDBMS you have only structured data, right? Only structured data, because you need to follow strictly your RDBMS rules, your ACID properties, and your integrity rules needs to be adhered to. But look at NoSQL data, where you can simply copy any data into your HDFS layer.
Yeah, that's correct.
So your unstructured data, your semi-structured data like your XML files, your Word files, your log files, your PDF files, your documents, your emails, all these things would be considered as an unstructured data where you need to copy. So your RDBMS will not handle this kind of data, because and again you need to scale horizontally, right? So Hadoop provides you a solution where you can scale up horizontally to as much sure you can. You don't need to change the schema. Now, if you compare your RDBMS and NoSQL schema settings, right? So on your RDBMS, it needs to strictly adhere to a strict schema, and say you want to update a table. So what you need to do, you want to update a field in the table. You need to come up with a new schema, right? Take the backup of the existing data and copy this data into the new table. Now with the NoSQL database, you don't need to change the schema. Okay, you simply add the new column and you can start populating the details into the NoSQL database.
Okay.
Right. So I mean, some of the examples.
Kumar,
Yes.
see, I have one data which is unstructured data, but with a limited quantity of data. So would you recommend Hadoop for it, or do we have any other alternative to Hadoop with unstructured data and less quantity?
Well, that's a good question, right? So typically when it's a Hadoop as a solution, right, we can start off as, like, say, a minimum of 5-node cluster. Right? So if you have a limited data, and if it is a variety of the data and which is not being handled by your RDBMS, yes, obviously we are looking Hadoop as a solution, and Hadoop as a solution, because the another important thing is it is open source, it is freely available. So there is no other solution that can provide you at the very least expensive, because in Hadoop you're not paying anything for the software or for the maintenance, right? Okay, let me say this way: you will only be paying for the support and the maintenance, and the software is free for you. I think that is not available with any other solution. And if the data is very limited, right, what you can do is you can come up with a small cluster, like, say, a 5-node cluster. Maybe you can start with a minimum of 5-node cluster, and from there you can actually scale up.
Okay, at what point of time do we need to decide on this 5-node cluster or a 10-node? Does it all depend on the amount of data we have? Or,
exactly.
Okay.
Yeah. So the amount of data that is coming inside your cluster is what will decide you on the size of the cluster. As you being an Hadoop administrator, you need to forecast the amount of data that is coming into, right? As you being or you can say as an architect, you need to see how much data is coming inside the cluster and how much data is required to be at any point of time that needs to be residing on the cluster, and what kind of jobs people are running, right? So that's exactly the solution, right? So what is the solution you are looking at? Your solution, all these examples I have given previously, based on the solution, how much data needs to be residing on your cluster. Now, it doesn't matter whether it's a 5-node cluster or a 10-node cluster. It again depends on the kind of hardware you're procuring. Okay, you can start with a server, with a single server of, I mean, like, say, each server of capacity about 10 terabytes. And if you talk about 5-node cluster, you're talking about 50 terabyte cluster. Right? So 50 terabyte with a 5-node cluster. Now there is something called reliability here, or with Hadoop, where each of the data that you copy into the cluster will be replicated 3 times. Right? So if you copy a 100 MB file, the space that you actually need would be 300 MB space on the cluster. Right. So that is how you need to consider. I mean, as you go through this, more advantages, and as you see the features, you'll get to know what that replication factor is, right? So replication 3x is the default, and that will help you. So as the data is coming inside your cluster, what is the solution you're looking at? How much data you need to have at any point of time to run your analytics? So that would decide the size of the cluster. In terms of size, when I say the size of the cluster, it would be you think in terms of the storage capacity. Okay, do not look at the way in the number of nodes of the cluster. Look at the storage capacity. And the reason I said it's a 5-node cluster is because we talk something called reliability, where the data is replicated 3 times. Now, if you come with when you say a replication of 3x, right? So 3 times is each of the file will be stored 3 times. That means 1 block. Again, there is something called the file will be split into multiple blocks. So these blocks will go and sit into any of the data nodes, or I mean any of the servers. Okay, data node is something which we'll introduce later. So each of the server. So if one server crashes, you will have some other nodes or some other servers from which you can recover the data from. So the replication, by default, the replication factor is 3, and to make sure you take the proper advantage of your Hadoop cluster, we can start with say 4-node or a 5-node cluster.
Okay. When you say this a 5-node or 4-node cluster, you want to include number of servers? Are you referring to the number of servers in that cluster?
Exactly, yeah. I mean, the nodes is something which I will explain to you. So I think that is too early to introduce the node concept. The servers. Okay, so there is something called a master, because this is actually a master and a slave architecture. So master node and the slave nodes, right? So slave servers. So when I say node, I mean you can take it as synonymously referring to the server also. Okay, so what I'm saying is 5-server cluster where 1 server will be master and 4 servers will be serving as your slaves. Okay, and slaves is where all your data will be stored in. Okay. So maybe we'll spend more time, and as we go through the session, you'll get an understanding of that. And at some point of time, you can come back with the same question, or you can come up with a solution. Say what exactly you have the data and how much capacity of the cluster you can come up with.
Okay. Yeah. Thanks, Kumar. I'm good.
Sure. Definitely. Okay. So. Okay, so we'll spend one more time, guys. Sorry, I mean we'll take 1 more minute and then we'll wrap up for today's session. Any questions? I will throw up for the questions. Any other questions, guys? Any other clarifications you want? Any concerns? Any way you want me to improve the way I deliver? Anything you want me to let me know? I can change. All right. So Divya is saying no. It's good. Thanks, Divya. Pavani is good. Okay, so great, guys. Sridhar is good. Perfect. So as I said, guys, anytime you have a question, please raise a hand or type into the chat window. Okay, so I'll try to address your question at that point of time, and try to see. I will address. Just want to make sure you keep your questions related to the topic that we are discussing, so that we don't jump here and there. But I will make sure any question that comes in, everything will be addressed. Okay, so we'll make sure your questions are addressed and you're good to go. Okay. Somebody saying good. Yeah, thanks for the acknowledgement. Thanks for that comment, Samba. Really boosts my confidence.